This is section 2.1. In this section, we continue to study transformation T on the vector x. We have seen in the previous section that we can represent x in the Euclidean space Rn, and the operation T can be represented by a matrix. The output y is equals to Ax, where A is m by n matrix, and the input is Rn space, and the output is Rm. In this view, transformation is simply matrix vector operation, A times x. Now, we wish to consider the case where it is advantageous to convert x into another basis. Let's call this basis B. And A changes to another matrix called D. How it changes we'll discuss later. But in this example, we wish D to be as simple as possible. And in our case, let's focus on the diagonal matrix case, where D represents the same transformation T in the B basis as a diagonal matrix. Why we do that is because anything D multiplied by a vector, when D is a diagonal matrix, the multiplication is very, very simple, computationally very simple. So in this basis, let's call this x of b. D multiplied by x of b is y of b, the output y in the b basis. This is the equation showing this fact. Yb is equals to the operation d times x of b. Now let's remember how we convert from the standard basis to the b basis. We basically do this. We take the input x in the standard basis, and we pre-multiply on the left by p minus 1, where p contains the columns of the basis, representing the b basis. So here is the fact. X of b is generated by p minus 1 times x in the standard basis. So this fact is also here. Now the operation on the b basis is d times x of b. This gives us y of b in the b basis. So we reach this point in the equation, and because most of the time we want the output to be in the standard basis, to convert a b basis to a standard basis, we pre-multiply on the left by p. So we get p, which changes from b basis to the standard basis, multiplied by d, which is the operation of a in the b basis. P minus 1x converts x from the standard basis to the b basis. So these three operations, PDP minus 1, represent actually A, the operation, the transformation in the standard basis. In the eigenvalue and eigenvector idea, what we usually have is that the basis P is actually the eigenvectors. D is the diagonal matrix containing the eigenvalue. So this is the relationship of linear transformation and eigenvector eigenbasis. We'll see that in the work examples 8.1.5 B slides. Thank you.